Today, we're going to start talking about something different than parametric curves. And the big question that we have to get started is, if I wanted to describe to somebody where a point in the plane is, how would I do that? So let's draw an axis. And so what we're used to doing is maybe we tell them that we have the point 2, 3 or something like that. This description tells us that we've moved 2 units positive in the x direction and then 3 units in the y direction. And that tells us how far we've moved vertically and how far we've moved horizontally. And sometimes this is the easiest way to describe something. Like if I was talking about how I moved around New York City, we're moving like in a grid. And so I could say I moved 2 blocks east and 3 blocks north or something like that. But sometimes it's more convenient to say, okay, I rotated 30 degrees and then I moved 5 units in that direction. And in that case, that's hard to describe with an XY coordinate. We could do it, but it's not as easy. And so what we're going to do now is we're going to talk about polar coordinates. And when we deal with polar coordinates, we're going to do exactly that. We're going to report an angle and then how far we've moved in a particular direction. So with polar coordinates, the way that we write them is we write them in the format r theta instead of xy. R tells us how far we've moved, and theta tells us what angle we've moved at. Okay. So if we look at this, when we're doing a polar coordinate grid, these are polar coordinates, r theta, then we have a grid like I've drawn over here, the circular grid, because what we've done is we take the angles and then we're moving at some like radius. The r is like a radius of a circle that we're at, because that tells us the distance that we've traveled along that particular angle. So let's just jump into this. This seems weird, but I promise it's not as bad as it seems. So if I want to plot the point 2 comma pi over 6, the pi over 6 means that our angle from the x-axis is pi over 6 units. So that would be over here, 30 degrees. And then the 2 tells us that we've traveled 2 units in that direction. And that's all starting from the origin, which is sometimes called the pole when we're thinking about polar coordinates, like the North Pole or South Pole. Okay, so if I've done 2 units along pi over 6, so this is my pi over 6 line. I've traveled 2 units from the origin, so that's 1, 2. So it looks like I'm ending up right here. So that's my point 2 comma pi over 6. Okay, so if I wanted 3 comma 3 pi over 4, 3 pi over 4 is along here. So I'm going to travel along that line 3 units. So I get 1, 2, 3. So that would be my point 3 comma 3 pi over 4. See if you can try some of these other ones on your own. 0 pi means I travel along the x-axis in the negative direction 0 units, which means that I don't move at all. So I stay at the origin or at the pole. So that one, that is my 0 pi, 0 comma pi. 4 comma pi means that I move along the negative x-axis 4 units. So I'm going to go 1, 2, 3, 4. That's my 4 pi. 4, 0 means that my angle is 0 and I've moved 4 units. 0 as an angle means I'm moving along the positive x-axis. So I'm 1, 2, 3, 4 units along the positive x-axis. Okay. This next one's interesting. We have a negative radius in this case. So this means I start out in the pi over 6 line, and I travel backwards. So I start from the origin and I shoot myself backwards along that line, which means I end up moving in this direction, okay, by 2 units. And so I'm going to end up 1, 2. I'm going to end up right here. Hopefully you can see that yellow dot. That's this one here. We noticed that another way of representing that point could have been that I started out along the line 7 pi over, or sorry, that's going to be in my second coordinate. So I started out at the angle 7 pi over 6, and I traveled a positive 2 units in that direction. The interesting thing here to note is that there are multiple ways of representing polar coordinates. So if I was thinking of just normal XY Cartesian coordinates, there's only one way to represent a point. I've moved 5 units in the X direction and 2 units in the Y direction or something like that. Here we have multiple ways of representing the same point. I can say I traveled to pi over 6 and then I went backwards 2 units. That's this one. Or I could say I traveled to 7 pi over 6 and then went positive 2 direction. So these are equivalent. There are infinitely many equivalent ways to represent a single point in polar coordinates, which is kind of fun. Okay, so let's look at these other ones. So this next one, I have 3 and then negative 2 pi. So that means I'm traveling in the negative direction, negative 2 pi over 3. Negative 2 pi over 3, remember from a trig, is equivalent to adding 2 pi to that. So let's see, 2 pi is the same thing as 6 pi. Nope, is the same thing as, yes, 6 pi over 3. So this is going to give us 4 pi over 3. So let's see, that's over here. So 4 pi over 3 is equivalent to negative pi over 3. And then we're using 3 units in that direction. So 1, 2, 3. So this would be my point here. So that point is equivalent to the point 3 comma 4 pi over 3. Okay. And so then negative pi over 2, that's the same thing as 3 pi over 2. We're traveling from counter or clockwise from the positive x-axis. So let's see. So this point will be equivalent to negative 4 comma 3 pi over 2. So if I start out along the 3 pi over 2 and then move negative 4, that means I'm shooting backwards in this direction. So I end up at the point 1, 2, 3, 4, this point here. Oh, we notice that's the same thing as positive 4, positive pi over 2. So lots of different ways to represent that point there. It's kind of fun. So we've got a fun smattering of points here. We'll get some practice in class graphing more. One question that we could ask is, can we convert between Cartesian and polar coordinates? So we can imagine adding an XY axis here, just our normal Y axis, our normal X axis, and then saying, okay, well, can I say how far I travel in the X direction and in the Y direction to get to our particular point? So if I had the point 3 comma pi over 2, that point is a fairly easy one to deal with. That's on the Y axis. 2, 3, that's this point up here. So in Cartesian coordinates, that's just the point x is 0, y is 3. Okay, so that's equivalent to the point 0, 3. It gets a little bit more complicated if I take points that are not on the x or y axis. So if I look at that next example here, 8 comma pi over 6. So that is going to 1, 2, 3, 4, 5, 6, 7, 8. That's going to be this point over here. Let me emphasize that in a different color. It's going to be this point out here. And so the question is, what are the x and y coordinates here? So I have to ask myself, what is this distance? That'll be my x coordinate. And then what's this y distance? What's the y distance? The way that we can do that is we can draw a triangle here. We've got a nice little triangle. The angle, the base angle here is my pi over 6. And so the 8 is the hypotenuse. So let's label this correctly. So this will be y, this will be x. So if I think about my trig functions, cosine of my angle will be equal to adjacent over hypotenuse. So x will just be 8 cosine pi over 6. And y over 8 will be sine of pi over 6 because that's opposite over adjacent. So y will be 8 sine of pi over 6. So my coordinate here will be 8 cosine pi over 6, which you can get a value for that. My y coordinate will be 8 sine of pi over 6. And so we can do this in general if we want to convert from polar to Cartesian coordinates. I'm just going to do r cosine theta to get my x value, r sine of theta to get my y value. This all comes from drawing triangles, just like I did up here. So if I wanted to convert this point below, my x coordinate would be -4 cosine 2 pi over 3. I'm going to let you guys do that calculation. Cosine of 2 pi over 3 gives me -1/2. So I'm going to get 4 times -1/2, which will give me a +2. My y will be -4 sine 2 pi over 3. Sine of 2 pi over 3 is √3/2. So 2's will cancel out. I'll get -2√3. So this point in Cartesian coordinates is 2, -2√3. Okay, it's good to be able to convert back and forth between Cartesian and polar coordinates, especially as we start graphing things.